So I already asked how many of you use DXR. It looks like maybe 2/3, half to a 2/3, something like that. For those that don't, you're going to see lots of demos in about a minute. It's our search and exploration tool for large code bases, and we are about to land a long-running branch, which has been so long-running and is so far-reaching that I've decided to call it DXR 2.0. And it improves every part of DXR, touches every subsystem. I didn't mean for it to be a almost rewrite, but that's what happened. So today's talk has two halves. I'm going to show you the whizzy new things landing in 2.0, and the second half is you're going to help me choose the whizzy new things for the release after that. And we're going to stop having these long-running branches. I don't usually do that, but this happened by accident. Whole big pile of people have been helping out with the project. I was shocked last night. I'm like, oh, let me get the 7 people who have helped in the last year. These are the ones just in the last year who have contributed just code plus Kendall because it's so much stuff. Our ops superheroes. Let's see what they've added. I've been thinking as DX of 2.0 as like a multiple brain transplant. We've rewritten several of the innermost subsystems, or darn close to it. And most important, we've replaced the back-end storage. SQLite's gone away with our custom C++ trigram index that nobody was maintaining, and Elasticsearch is here to stay. Elasticsearch is orders of magnitude faster for the kinds of common operations we do. More scalable, we can cluster it, does all these little tricks, fuzzy matching. I can do efficient result counting, so Jay Ruderman can do Google fights. We can do faceting and scoring. Boy, scoring hurts in a relational system. We can harness the fuzzy stuff to do did you mean kind of stuff. Sparse attribute storage, so we don't have to continually think of, well, how do we represent the sum and union of all programming languages in a rectangle? Extreme flexibility of tokenization, the ability to, hey, this is cool, you can pull out individual lines of source files that we've indexed so we can get context for search results or load big, huge, crazy files incrementally over the web. Really a useful thing, but of course this meant we had to replace everything in the system that assumed a relational model. Fun, fun, fun. So before we embarked on this road, we did a very careful study of various storage engines, thinking as far ahead into the future as we could possibly fathom, and we're pretty satisfied that Elasticsearch is going to take us a long way. Aside from Elasticsearch, other things that have been rewritten include the HTML rendering pipeline. Now we emit well-formed markup, no more like 3 close anchor tags in a row. We do all this stuff at request time, so we don't have to build and store 30 gig of HTML per tree on an NFS store that it's like $10 a kilobyte or some ridiculous thing. New multiprocessing engine, which is no longer strange. New query parser, actually a parser now, yay! Config system is not stupid anymore either. So what kind of cool new features has all this backend stuff gotten us? Well, speed is probably the most visible thing. Before, some kinds of queries would be slow because we'd forget to make an index, or SQLite's planner would do something silly and naive. Well, the Lucene behind Elasticsearch doesn't know how to be slow. It won't do table scans. Everything is indexed for it. At worst, you get an index scan out of it. Also, it has mad crazy caching of results. Come on in, enjoy. So a lot of DXR's queries are of the form this and this and this. If you have a couple of words, they're ended together. So the neat thing you can do with ES is you can say, hey, I want you to kind of break up your caching. I want you to cache, yes, this and this, but also cache each branch individually. And we cache these things as bitmaps, and so what we end up with, LRU style, is we end up with the set of all star.cpp files shoved in memory as a bitmap, and we can just do set math on these things so crazy fast. And Lucene compresses them and hashes them. So many cool data structures. We get tons of mad speed out of it. When I was recording this, you can actually see intermediate results pop up before I can even finish typing what I was typing. And I'm typing from a script here. I'm not even thinking on my feet. So that's how quick this is. Better C++ analysis wasn't really an intention of this release. It's just something that sort of happened as we cleaned things up. We corrected a whole bunch of weirdnesses. And these are just the ones that I could convey tersely enough to actually fit on a slide. A big one was I audited the compiler plugin's location handling. So we have this plugin that lives in Clang and bails data off to the side. And we suck it in. That's what you get. So as a result of fixing the location stuff, we can probably find lots of things we couldn't before. Probably we're just throwing lots of things on the floor, especially around macro sites, macro calls. Another of my favorites is the callers query. Find the calls to this function. Well, now we point to the actual call site instead of like to the top of the function that might contain the call site. So that's cool. So C++ is great and everything, but there are other languages, which is why DXR 2.0 supports Rust and Python. And I got to thank Jeff Bradbury and Osmos for the Python thing. Hey, come on in. Python support is pretty basic right now, but it still does a whole bunch of useful things already. We can find subclasses of things, overriders of methods. We can find modules by name, and it even understands that a folder with an init.py file in it is a module of sorts. And one of the things I'm particularly proud of that M. Kelly wrote was we trace the import lineage of symbols, functions, for example. So if you have a function somewhere deep in a package, maybe in a private module, and you've lifted it up, imported it into an API package that's the public interface, and then imported it from there to somewhere else, and then if you look for the definition of it, it skips that interstitial step and takes you right to the source. So happy, smart, useful stuff. As for Rust, we're going to index the Rust compiler and servo for starters, and there are rumors that we might go a little more crazy and do community packages, like everything on crate.io. DXR understands Rust-specific constructs like impls, can hunt them down for you, and a big shout out to Nick Cameron who did our Rust support. We actually have our analysis in the Rust core, not some crazy, janky, on the side plugin that's going to go out of date all the time. And it's battened down by tests both in Rust and DXR, which runs against each nightly, so we know right away. It's actually happened once already, but I knew within 24 hours that something had broken. But these two languages are just the beginning. The future is bright. We can do JavaScript now. We can do various homegrown IDLs. These are possible next steps. And since we've removed all the C++ assumptions from the code base, we've made things a lot more general. How we work internally is something I call like line tagging. We lay down these breadcrumbs to find later. These needles, we call them, as in needles in a haystack. For example, we would tag this line up here as defining a Python class called member function tests. Okay, we should attach that data to that line. Now, of course, we can have more than one tag on a line. Why not, right? So we could also say this line defines a Python class that subclasses single file test case. And this would power our subclass searches or find subclasses menus and so on. Likewise, we can tag this line down here as defining down here, there we are, as defining a function with a given name, and also a member of a given class. It's a method on this class. So this simple approach is completely language agnostic to the point where it's not even limited to programming languages, right? We could just as easily teach it to find occurrences of names in a legal document or the occurrences of CSS classes in some markup. So we can get this, we can push this a long way without having to change anything about the schema. Now, previously, a file's contents were indexed as a single entity, and that's still how it is in production. Now, this led to some weird behavior where a multi-word search query would have all its words ANDed together to choose the files to show you, but then have those words ORed together to choose the lines to show you. So not every line had all your terms on it. It's kind of unexpected, kind of bizarre. In 2.0, it's just like grep. We find the lines that match all of the words you type. As you can see, if I type all the things, every result contains all three words. Yay, just like it should. Now, if you want to match the whole phrase, you just put quotes around it, and then they're contiguous. Now I wanted to kind of float this to everybody in the room. Who thinks that we should kind of concatenate together consecutive text terms and find the phrase by default, unless you maybe put like capital OR between the words or something? Anybody want the phrase matching by default? Nobody? Okay, cool. I will not build that.
I think we are familiar with this behavior with Google, basically the default behavior, and I think we all know that using quotes is enough here, so I don't think we should bother for that.
Yeah, I've been lifting a lot from Google, colon syntax and everything. Okay, excellent. Brilliant, brilliant. I'm actually going to take notes while we're doing this, and this will help power the future.
The possibility of a not operator is interesting.
We have one. It's minus.
You got one?
Yeah, it exists right now. You can use it on Amazon, in fact.
Oh,
Yeah, try it out. Let me know if it surprises you in any way.
well.
I love when people ask for features we have.
It should not.
Easy.
Nope.
Yeah.
All right. Awesome. Thank you very much. So, parallel indexing happens now. I was saying before we got started, this will help us get all the trees in MXR index, 30 or 50 trees or something, and then we have like a line, we have a whole ticket collecting people who want their stuff in there. And it also will mean that indexing different trees is independent. So if Com Central's build breaks or something, Moz Central won't be held up. It never breaks.
Never breaks.
No. We've got a nice HTTP API now with no strange format equals JSON query string parameters. And it lets you do things like write a DXR search plugin for your editor, which Osmos has done. He's plugged this thing into Atom. And you can search for files. It'll find the corresponding local file and pull it up for you when you click. Or you can search for lines of code, do structural queries, anything you like. It all works very nicely. Performance is fine, and might be a few guitar solos hidden in there as Easter eggs. Permalinks or something that was who wanted permalinks in here? Okay, everybody's like, yeah, my links are all breaking. That exists right now in staging, and it keeps your highlight regions and everything, so you can paste your links into Mozilla, and it'll work forever. Yes.
When will that be put into release?
As soon as 2.0 lands,
Okay.
it works on stage right now. You could link to stage and put up with breakage, but. I was talking about, when is it all going to land? When is it all going to land with Hubar yesterday? And, he's got stuff to do, and I've got a couple of bugs to fix, but I've been saying 2 weeks for like 3 months now. Real soon now.
Cool.
In the meantime, enjoy staging, which works most of the time. Even though it's split across 2 data centers, it's still faster than production. So I'm really happy and proud and cheerful about this. So MXR has its identifier searching, right? But it's not that accurate because MXR is just kind of like guessing at stuff with regexes. And well, now we have that in DXR, and it's correct all the time. Just type ID : whatever. You can find ID foo finds all the foos. ID bar finds all the bars. And as you can see, there's all kinds of things in here. There's a struct, there's some variables, there's a class definition. It's a tremendously useful first cut filter for getting started. And it performs way better than it ought to. I'm not even sure why it's so fast. Binary file browsing. Right. So we can see binary files in listings now. And if they're images, we get to see their thumbnails in the listing, and we can drill in. If they're not too huge, we can see them. Yay.
If they're SVGs, what do you show?
What do I show? I think I still show the markup, maybe?
Security risk.
I don't know what we show. Well,
Can't
maybe.
render it.
Oh, I can't read. Oh, that's cute. You have to show me how to own somebody with an SVG later.
You show a picture.
Do we? Thank you. Please file that bug, Peter. Apparently it's a security risk of some kind. Yeah, interesting.
Sometimes I want the picture, sometimes I want the markup. What to show there is
Yeah,
a hard decision.
I'll need to learn more about that. You can try all this stuff on staging right now. It exists. Find bugs, give feedback, expect intermittent breakage. Right now, I think none of the context menus are working for some reason. I think it's a build problem. But there is more. The entirety of DXR 2.0 is built on a flexible plugin architecture. Figured while we were at it, as long as we were writing, we'll rewrite it hookable. A plugin can add entirely new languages, entirely new query types, like Rust. Rust is a plugin. Python is a plugin. C++ is now a plugin. We can add new query types, like Rust adds the impl type. And we can add new cross-references just as easily as overriding a couple of methods. The most common hooks are fairly intuitive. They correspond to what you see on the screen. Coloring stuff, hooking menus to things. You just make a subclass, implement whatever hooks interest you, and then register it with a one-liner setup tools entry point. And so far we've kept the plugins inside the DXR code base just because the API is kind of flopping around still, but the flopping is really slowing down. So while you're welcome, if you want to write a plugin, please upstream it to DXR and we'll include it, and we'll have batteries included and everything. But if you're doing something wacky, just experimenting for yourself, nothing keeps you, technically, from developing and distributing plugins as separate things on their own. Our plugin writing guide is on Read the Docs. It is pretty extensive, starting with an overview of DXR's internals and then delving into every little corner of the API. And when that fails, there's always the static channel on IRC where we all hang out. So that concludes the first half of the talk, the Dog and Pony Show. But what is next? Putting 2.0 into production, obviously. But after that, I want to get your opinions on these things. We have a couple of ideas. Here are some of the possibilities that were floating around in my brain. And I want to take some self-selected, unscientific polls of the interested users in the room.